Deep within the specialized chambers of the botanical world, the Venus Flytrap operates with a hydraulic trigger system that is faster than the blink of a human eye. This plant is a masterpiece designed to function as a high-speed mechanical trap in a nutrient-poor environment. The machine facts of the trap reveal that it is powered by a rapid shift in cell turgor pressure. When triggered, the lobes of the leaf flip from convex to concave in less than a tenth of a second. It is a biological snap-action switch that requires no muscles to operate. This engineering solution relies on 3 tiny trigger hairs located inside each lobe. To prevent false alarms from falling raindrops or debris, the plant uses a sophisticated counting logic. It only snaps shut if 2 different hairs are touched within a 20-second window. This digital processing ensures the plant doesn't waste the massive amount of energy required to reset the trap. Once closed, the plant continues to count. It requires 5 more stimulations from the struggling prey to begin the seal and digestion phase of the cycle. Diagram of the trigger hairs and the electrical signal pathway inside the trap. Psychological facts suggest that this plant demonstrates a form of cellular memory. It must remember the first touch while waiting for the second. This short-term storage of information allows the machine to distinguish between a passing breeze and a high-calorie meal. Humans must treat and care for the rare peat bogs that house these green machines. Poaching and the drainage of wetlands act like a power cut for these plants. Stewardship of the swamp is the only way to ensure these natural traps continue their ancient watch. The history of the flytrap is a record of extreme adaptation. Evolution reprogrammed a standard leaf into a predatory jaw. It proves that when the environment lacks the fuel of nitrogen and phosphorus in the soil, life will engineer a way to harvest it from the air. Nature facts reveal that the teeth of the trap are actually interlocking cilia. They act like the bars of a cage, allowing very small insects to escape while retaining the larger, more nutritious targets. It is a built-in filter that optimizes the plant's energy return. Caring for the flytrap is a form of environmental maintenance. By protecting the quality of the groundwater, we ensure the chemical balance needed for the hydraulic fluid inside the plant. If the water becomes too mineral heavy, the delicate snapping mechanism stalls. The machine facts of its digestion show it functions like an external stomach. The plant secretes enzymes that dissolve the insect's soft tissues into a nutrient soup. This liquid is then absorbed back into the plant's chassis to power the next growth cycle. Engineering comparisons often liken the flytrap to a bistable spring. It is a structure that is stable in 2 different positions, but requires only a tiny nudge to flip from one to the other. It is a level of mechanical efficiency that inspires modern soft robotics. Every snap is a lesson in the power of selectivity. We often rush to react to every stimulus, but the flytrap proves that waiting for the right moment is more efficient. It is a reminder that knowing when not to act is just as important as knowing when to strike. Every bog is a laboratory of botanical innovation. By respecting the quiet work of these green predators, we recognize the complexity involved in desert and swamp survival. It is a partnership between the sun, the soil, and the mechanical leaf that captures the wind. Let the Venus flytrap remind you of the value of precision. It does not hunt with speed across the ground, but with perfect timing in its own space. In your own life, being patient and setting your triggers correctly allows you to capture the best opportunities. Take care of the carnivorous hardware of our world. As we look toward the biodiversity goals of 2026, protecting the habitats of these hydraulic engineers is a high priority. Respect the wetlands and protect the bog, so the snap of the trap may never go silent.